Astronomers trained a neural network to sort through a lot of data from a camera that looks for planets. This was a first for the field. Because of this, the neural network found a whole new world. The new planet, called Kepler 90I, was hiding in all the data that the Kepler probe had been gathering. It now joins 7 other planets that orbit an alien star about 2,500 light-years away. This makes the Kepler 90 system tied with ours for having the most known worlds. NASA's Paul Hertz said at a news conference to announce the find that Kepler has already shown us that most stars do in fact have planets. Scientists said, "Today, Kepler proves that stars, like our solar system, can have large groups of planets." In the days leading up to the news briefing, there was a lot of talk about the chance of finding life on other planets. Even though it shouldn't be a surprise that this isn't the case, this news does show how machine learning can help us learn more about worlds in the cosmos that might be interesting. There are 100,000 things to see and do. After its launch in 2009, the Kepler satellite spent 4 years looking at a single area of the sky with 150,000 stars. Its job was to watch for small drops in sunlight that would show when planets moved in front of their own stars. When scientists find this kind of signal in the data, it lets them figure out not only how big a planet is, but also how far it moves around its star. So far, Kepler has found 2,525 planets, but there are almost certainly more hidden in the data somewhere. But it might be hard to prove that a planet exists. Kepler gathered a huge amount of data, which would be impossible for a person to sort by hand, because it includes several quadrillion different possible orbits for planets. Even if a star is getting dimmer, that doesn't mean a planet is to blame. Sports stars, star neighbors, and other things can leave a mark that looks like a planet's. Chris Xiaoyu, who works at Google AI, saw how hard the problem was and decided that neural networks would be the best way to solve it. There have been other times when machine learning techniques were used to filter and classify Kepler data, but Xiaoyu's neural network offered a much better algorithm. When I found out that the Kepler mission had collected so much data that scientists couldn't look at it all by hand, he says, I became interested in using neural networks in astronomy. We wanted to use this method on the whole universe and teach a machine learning system how to find planets in orbit around faraway stars. An amazing new point of view. Neural networks are based on how the human brain works to handle information, as their name suggests. They can be taught to spot and sort things, such as how to tell the difference between pictures of dogs and pictures of cats. If the computer looks at enough cases, it will soon be able to tell the difference between cats and dogs on its own. Xiaoyu taught a network enough so that it could figure out what makes each planet special. He started teaching the program to tell the difference between real planets and signals that can look like planets by taking 15,000 signatures of real planets from the Kepler dataset. NASA made Kepler, which is a camera that can be used in space. After putting his machine through a number of tests to see how well it learned, he found that 96% of the time it correctly named planets. With unexplored areas to discover, Kepler 80G is the 6th known world in its own solar system. It is one of the planets. Kepler 80G is a planet that is about the same size as Earth and takes 14.6 days to go around its star, which is a much smaller and redder version of the Sun. The neural network also knew that Kepler 90I was there. This planet is the 3rd rock from its Sun, which is a bit bigger and hotter than our Sun. Its year is only 2 Earth weeks long. This world is also a little bigger than Earth. The orbits of planets that are closer to the star than Kepler 90I keep getting smaller, while the orbits of planets that are further away from the star keep getting bigger. Even though there are a lot of different people from different worlds, they are all crammed into a small space. For example, each of the 8 planets is about the same distance from its star as Earth is from the Sun. Kepler 90I is not a place I'd like to visit, Vanderberg says. We figured out that the normal temperature of the surface is probably around 400 degrees Celsius, which is about 800 degrees Fahrenheit. The top is probably boiling hot. He also says that Kepler 90 could have planets that haven't been found yet. He plans to test their neural network with Shalou by putting all of the Kepler dataset into it and watching what happens. But you shouldn't worry too much just yet about computers taking the jobs of real scientists. Jesse Dotson from NASA says this will definitely help astronomers. We will all work together on this. Moreover, in less than 4 years, a NASA effort to find planets found 5,000 likely worlds where aliens live. Over the past 4 years, NASA's Transiting Exoplanet Survey Satellite, or TESS, and the scientists who look for planets in the data it collects have been very busy. The team has now found more than 5,000 TESS objects of interest, or TOIs. This is a big discovery milestone for the project. There are possible exoplanets and other interesting signs among these TESS objects of interest. Astronomers chose targets from these TOIs to look into further with other tools and in more detail so they can learn more about what TESS may have seen. Since April 2018, when TESS was first turned on, 176 possible planets have been confirmed. After finding an object moving through the infrared, it takes more observation time to confirm possibilities for exoplanets. So scientists think that confirmation of planets will come after candidate planets have been found, even though the Kepler Space Telescope, which came before TESS, stopped making studies in 2013. It found signs of more than 2,000 planets that have not yet been confirmed. The data that the Voyage collected proves that there are more than 2,700 planets. TESS was made to have a mission that would last for a total of 2 years, with the first half of that time spent sweeping across the southern hemisphere and the second half in the northern hemisphere. Since its mission was extended in July of 2020, the spaceship has kept going in this direction. The team wants to keep making observations for at least 5 more years, which would put them in the year 2025. Because TESS spends a month at a time looking at the small bright stars in each patch of the sky, it is best at finding hot planets close to their stars, which tend to spin faster than other planets. So far, the project has found several planets, and each of them has a year that is only 16 hours long on Earth. TESS has also found a group of 5 planets that move in time with each other, a planet that might have water clouds, and planets that are likely to be eaten by their old stars. Catherine Hess, the manager of TOIs at MIT, said in the statement, "With data from the first year of the extended mission, we have found dozens of additional candidates for TOIs found during the Prime mission." The scientist said, "I can't wait to see how many multi-planet systems TESS can find over the rest of its extended mission and in the years to come." Thanks for watching this video.